Okay, the last two rules they go together. That's the zero power rule and the negative exponent rule. So we know that the negative numbers are any numbers less than 1 or less than 0. So if we can figure out what 0 is, we can kind of move down to the negative numbers. So I'm going to start off with a couple of patterns first, so we can identify what the 0 rule is and negative exponent rule is. If I have 2 to the 4th power, 2 cubed, 2 squared, 2 to the 1, and then 2 to the 0, this is what we're looking for. And we'll repeat the same pattern with another number. Well, let's do 3, because it's easy to calculate. 3 to the 4th, 3 cubed, 3 squared, 3 to the 1, and 3 to the 0. Okay, and we'll eventually get down to the negative numbers, and we'll see what the pattern is. Okay, so here's our exponential form, and we're going to solve this and get our standard form. Okay, so 2 times 2 times 2 times 2, that's 4. This is 16. This is 16. This one is 8. This one is 4. This one is 2. And if I continue this pattern, it's divide by 2. Divide by 2. So from there to there is divide by 2. Maybe we'll scoot this over a little bit. That'd be nice if you could do this with your paper, but so from one to the next, my pattern is divide by 2, divide by 2, divide by 2. So 2 to the 0 should be equal to 2 divided by 2, which is 1. So in this case, we have something to the 0 power equals 1. Now, does that hold true for all exponents and all numbers, all bases? So let's try this one. 3 to the 4th, 3 times 3, that's 9, times 3 times 3, that's 9 again, that's 81. So this is 81. This one is 27. This one is 9. 3 to the 1 power is 3. And we're looking for this one. Again, this one is divide by 3. And we can repeat this divide by 3 for my pattern, so identify the one with one exponent less. So 3 divided by 3, this 3 divided by this 3 equals 1. Now this pattern will hold true for any base. So I can say anything to the 0 power, anything to the 0 power is equal to 1. Okay, I say 3 to the 0 power is equal to 1. I can do this with a million. I can say a million to the 0 power is also 1. Okay, so this establishes my 0 power rule. Oops, didn't want that. Okay, that's my 0 power rule. Now, let's look at the negative numbers do. Let's see what this does. Okay, so right now I have exponents of 4, 3, 2, 1, 0, 4, 3, 2, 1, 0. Let's keep going. Let's continue this pattern down to the negative 1 and 2 to the negative 2. And let's just go one more to the negative 3 and we'll see what we get. 2 to the negative 3. Okay, so again, we established this one by using this pattern. So let's just continue using the pattern. Okay, this is one of your mathematical practice skills. Math practice skills is using patterns to help you solve problems. So I'm going to divide by 2. 1 divided by 2. I'll keep going. I'll just draw them all out while I'm doing this. Okay, 1 divided by 2 is 1/2. Okay, well if I divide by 2 again, I get 1/4. Divide by 2 again, I have 1/8. Okay, well, what's another way to write 4 that's similar to this? This is the same thing as 2 squared, that 4, but now it's a fraction. So they become the exact same thing as they were in their positive versions, just as a reciprocal. Okay, the same thing holds true for these negative numbers, 3, 3, 3, and let's make this negative 1, -2, and -3. This one will match this one. Oops, sorry. That was the wife calling. So if we continue this process of dividing by 3 all the way down, okay, so this one will divide by 3, divide by 3, and we'll divide by 3. Okay, we have some pairs here. So these are pairs. So let's highlight this one. This 3 squared should have a pair down here. Now the only difference is this is 27, and down here I should have a reciprocal of that number. Okay, I should have a reciprocal of that number. This is a pair, 3 squared and 9. I should have a pair down here, and instead of 9 I should have a reciprocal. Okay, and lastly this one here, 3 to the 1 should have a partner there, and instead of 3 I should have the reciprocal. Okay, so let's follow this pattern down. 1 divided by 3 is 1/3. That's a reciprocal of its partner. And same thing here. This one is divided by 3. I should have 1/9, a reciprocal of its partner. And again, divide by 3. I should have 1/27. Again, a reciprocal of its partner in the positive version. Okay, so that's what our negative exponents are. So I'm going to show you what your from your homework, what I want you guys to do, and just to identify these items. Let's go to here. Okay, so here's your negative exponents. Some of them have zeros, so let me do a couple of these. Let's do this one, 31, and let's do I would say yell something out, but I'm not there to hear you. Let's do these two. Okay, so this one and this one. I'm going to put them down here on the bottom of this page. So your notes might end up taking a lot of space, or a couple of pages, which is fine. Okay, here's question 31, here's question 36. All I want you to do is simplify this so you have no negative exponents. Okay, so what that means is this 5, and then I have this a to the -2, a to the -2, and then I have this b to the 0. This b to the 0 turns into a 1. So this one can essentially go away. My zeros have no effect on my equations because they're multiplying by 1. This will turn into 5, and in the denominator I'll have a squared. It goes to the denominator, moves to the opposite location, and that becomes a positive. Okay, just like here when I had 2 squared, the negative version, the 2 squared ended up on the bottom. So this ends up, this 4 down here is the same thing as writing 2 squared. So I could write something like this down here, 2 squared, 2 squared. Okay. And in this case, instead of a base of 2, is a base of an a. Okay. So this is what I'm looking for, something with no negative exponents. Okay. This one here, 36, same thing. Again, this exponent is only attached to the v. This 4 exponents only attached to the u. This 8 has an exponent of an invisible 1. If it was a 0, it would go away. So it's got an exponent of 1. So when I write this out, I'm just going to write 8u to the 4, and then this v to the -1. I'll do it in different colors so you can see where it goes. V to the -1. This ends up moving to the denominator. So this turns into 8u to the 4 divided by v to the 1, or just v. The 1 doesn't have to be there. Once it moves, it becomes a positive. The opposite is the same. If it was a negative on the bottom, it'd go to the top. Okay, so this is what we're looking for. Okay, your homework is to complete. I know there's 40 questions here, but it is fairly easy. Most of you might already be done by now. Okay, make sure that this all ends up in your notes. The zero, power rule, negative exponent rule, power to power rule. This one, the quotient rule, and the product rule are probably the most useful ones, and the ones we're going to be using for scientific notation, which we'll cover on Tuesday. I want to see you guys. We'll cover scientific notation and how to manipulate those equations and review. Your test will be Thursday. So Tuesday we're going to do one lesson and review. Your test will be Thursday. Okay? Be nice to the sub.